Hey everyone, welcome back. Let's talk about one sample t-test. This is a real assignment we used to do in Sacramento, where the week before the assignment, give students a quarter, say find a parking meter downtown, and pop it in and see how much time you actually get for your quarter. It's supposed to be 15 minutes, which is 900 seconds. Recorded them, so these are real times, and this is back when they were mechanical. The hypothesis here is, let's see, the goal of this analysis is to test the following research hypothesis. Does the mean sample of 30 parking meters differ from the expected population value of 900 seconds? So is the time different from 900 seconds, which, excuse me, which is 15 minutes? Is the research hypothesis above two-tailed or one-tailed? The answer is two-tailed. Why? Well, this differ means that the hypothesis is supported if they rip you off time or if they gave you time. So because it's either direction, it is two-tailed. So it doesn't specify just one of those tails. Even though they probably rip you off, it'd be your guess. So what is the expected population value of mu? It's 900 seconds specifically, because that's 15 minutes. Times 60 seconds is 900. To write the hypothesis, starting with the alternative, like I always do, this is turning these words right here. Does the mean time of the sample differ from the population value of 900? What we're saying is that the sample mean will not, excuse me, what we're testing here is that the sample mean is not going to be equal to the population mean. So that is the not equal sign, and that is how you always write two-tailed ones. So if what we're hypothesizing is that whatever the value is, could be higher, could be lower, but it's not going to be equal to 900, where would we be wrong? What would be our null? It would be equal to mu, or 900 seconds. So let's go ahead and run this sucker. So we go into analyze and down to compare means and proportions. One sample t-test. We put our test variable into the box over here. Options, nothing under there. Where it says test value, the default is 0. It tests if a thing's different, a sample means different from 0. Our test value is actually 900 because we want to know if the sample mean of seconds differs from 900 seconds, the population parameter. Click OK, and that's what we needed. So here's our output. There we go. One sample t, scooting on down. What is the sample mean? Sample mean is right up here in one sample statistics. It's 912 seconds. There's your standard deviation, by the way, even though I didn't ask for it. What is the difference between the sample mean and the population expected value? So you could do that the hard way or the easy way. You could do some math. We have a mean of 912 in the sample. Expected value is 900. That's a difference of 12 seconds. That's one way to answer it. The other way is it just sort of does it for you. Oh gosh. One-sided p mean difference. There we go. Mean difference. 12. That's 12 seconds difference. The sample is 12 seconds higher. The question is that significantly higher or not? So let's see what we got here. We need to decide, all right, is that a big enough difference, that 12 seconds, that we would say, okay, yeah, the sample time does differ from the expected population value. To reject a two-tailed hypothesis, all we need is for the t-test to be statistically significant. We're going to use 0.05. So scooting on over, here's our t-value. There's our one-sided. That's not the one we use. We want a two-sided p-value, and it's equal to 0.027. And indeed, that is, excuse me, less than 0.05. Because this sig is less than 0.05, we say, yes, there is a significant difference between the sample mean and the expected population value. So in fact, what is that difference? Well, the sample is 12 seconds higher on average, right? Their mean was 912 seconds. The expected value was 900. That's a real difference, not just chance. Question one, using alpha, can we reject the null? Or sorry, question 6. Yes, we can, because sig's less than 0.05. Are you fully able to reject the null? Well, because there's only one thing that has to be true for a one-tailed hypothesis, that's also yes. That differs if you got did I say one-tailed? Two-tailed hypothesis. A one-tailed hypothesis, there's two things that have to be true. It's got to be significant. It's got to be in the direction you predicted. So why or why not? The significance two-sided is less than 0.05. That's sucker. So that's why we know it's a significant difference. So to calculate eta squared, this guy right here, there's a little formula up here. You take t squared, you divide it by t squared plus degrees of freedom. Degrees of freedom is n-1. It's also right here, by the way. So let's calculate this for number 8. What proportion of variability is accounted for by being in the sample rather than having the expected population value? Pull up calculator real quick, and let's do this. So I'm going to calculate the bottom first because I need to know that number. It's 2.327 squared plus degrees of freedom 29 plus 29. And that gives us, and I'm just going to have to write this down, 34.4149. That's probably enough decimals. That is our bottom right here. And then we just have to get the numerator, which is the t again squared. So 2.327 squared. I'm going to divide it by that number I just wrote down for the denominator, 34.4149. And that's 0.157, etc., which if you rounded it, that's going to be 0.16. That's why the answer is 0.16. So that's if you turn it into a percent, that's 16% of the variability is accounted for. So we have to fill out the T formula. Note this, not T formula, the T APA format. Note, some people look at this and think it's an equation. This is not an equation. This is just filling stuff out so you can write it in your APA write-up. So to get this information, I filled it in over here. We have a T with degrees of freedom of 29. The T is equal to 2.33. That's right here, rounded. Our p-value was less than 0.05, so we did less than 0.05. And eta squared, we just calculated up above, is 0.16. So that's where we get this whole thing. What's the meaning? The whole, what would you tell grandma? So to answer that question, we know that there's a significant difference between the sample mean of 9.12 and the expected value of 900. We know it's significant, so we can actually talk about what is the difference. Well, this one's higher by 12 seconds than what's expected for your 25 cents, right? So the conclusion, or what you tell grandma sentence is, well, there is a significant difference between what the city says they're going to give you and what they give you. In fact, they give you 12 seconds more time on average, and that's that mean difference. So final question, if the data had been ordinal or the sample size was very small, I'm basically asking you what is the backup test? And to do this, you want to pull up your matrix of statistical tests, which of course I did not pull up. So let me get our matrix pulled up real quick. Boom, 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 boom. There we go. So pull up the matrix of tests, and I'm asking you, what is the weed whackery backup test for one sample T? And to answer this question, all you got to do is, here's one sample T in the matrix. All you got to do is look at the row that's above it. What's the test that's named there? This is always your backup row, basically, for any inferential stat. If I tell you, look, you can't do the fancy stat, you got to do the weed whacker one. You would say Wilcoxon sign ranks test for single samples, which I put hopefully in here and said Wilcoxon sign ranks for single samples, and that's how you answer it. So hopefully you did you got to do your APA write-up. Note that you can alter the figures, so that's how you get the figure. It's really difficult to get one out of SPSS. So you just sort of right-click on it, do edit data or edit data in Excel, and then you can change numbers, change words to get it closer to what you actually want. So due this week is the your output exported in PDF or doc format. And this handout with your name and answer at the top and your APA write-up based on that template that I present out there. So that's it. Hope you got it right, and see you soon.